Section 1.8, absolute value. So in this section, we're going to be studying absolute values, well, equations involving absolute values, and inequality equations involving absolute values. First, let's recall what an absolute value is. We're really going to be looking at equations involving absolute values, and we only want to determine real solutions for both absolute value equations and absolute value inequalities. So, recall, the absolute value is just the distance from that value to the origin. It's just equal to the value, say the absolute value of x, is just equal to x if x is non-negative, and it's equal to negative x if x is negative. It is just the square root of x squared. So let's look at some absolute value inequality. And so if a is greater than 0, then the absolute value of a is just equal to if the absolute value of x is equal to a, then x is equal to plus or minus a. If instead we're trying to solve it, when a is 0, then, well, plus or minus the square root, plus or minus 0 is just 0, so we just have x is 0. If we're trying to solve the absolute value of x is equal to a, where a here is negative, well, we can't have that an absolute value is ever negative. So this has no solution. Let's do some examples. Let's say on page 170, write each expression without absolute value symbols. And so this is just pi minus 4 but pi is like 3.14, etc. And so pi is less than 4, so pi minus 4 is negative. And if you have an absolute value of a negative number, you have to change its sign. So let's multiply the negative inside the parentheses. So let's multiply the negative here inside the parentheses. So if I do that, I get minus a negative 4 is a positive 4, is 4 minus pi. Let me do problem number 20. So I want here absolute value of 2x. Well, this is the same as the absolute value of 2 times the absolute value of x. Absolute value of 2 is just 2. Absolute value of x, well, maybe I'll write this. I could either function or as the square root of something squared. Let's write it as the square root of something squared. So this will be x squared and then take its square root. And that is the absolute value of 2x. Let me do problem number 22. I want to solve each absolute value equation for x. So I have that the absolute value of 2x plus 5 is 3. So what's inside the absolute value must either equal 3 or negative 3, because the absolute value of 3 is 3, the absolute value of negative 3 is 3 also. So 2x plus 5 must either equal 3 or negative 3. Subtract 5 from both sides and divide by 2. Now, I can actually solve this because these are very nice numbers. So let me try to do that. And so let me -5 minus 3 is a -8 divided by 2 is -4. Next, -5 plus 3 is a -2 divided by 2 is a -1. So I have two solutions to this absolute value equation. X equaling -4, X equaling -1. Let me need to get some more room here. Smooth this down a little bit. Let me do problem number 30. Absolute x plus 5 over 2 plus 3 equaling 2. First, let me get fractions. So let me multiply both sides of my equation by 2. The 2's cancel, so you just get x plus 5 in absolute value plus 6 equals 4. Recall the absolute value of 2 is just 2. Subtract 6 from both sides of your equation. So x plus 5 in absolute value is -2. But how can a absolute value ever equal a negative number? Well, it can't. Therefore, this has no solution. So this equation here has no solution. Okay, so let's do problem number 42. The absolute value of x minus 3 is equal to the absolute value of 3x minus 5. Well, I can do this in two ways. I can say, well, the absolute value of this is going to equal plus or minus. So an absolute value is plus or minus. So therefore, what's inside will equal the same as what's inside. Or what I could do is rewrite this as the square root of something squared. So the square root of something squared is just its absolute value. So I can just rewrite each of these in the form the square root of something squared. So the way to solve this is just to square both sides of your equation. So this is a radical equation, but each of the radicals are solved on one side of the equation. So I can just square both sides of my equation to get rid of the square root. So this just says 2x minus 3 squared equals 3x minus 5 squared. And so let's square this. So I get 4, by the special product formula, 4x squared minus 2x times minus 3 times 2 is minus 12x. Plus 3 squared is 9. Equals, again, this is a one of the special product formulas, so it's a perfect square trinomial. And so this is just 9x squared minus 30x plus 25. Subtract 4x squared from both sides of my equation. Add 12x to both sides of my equation. Subtract 9 from both sides of my equation. And so let's try to factor this. And let's see if we can factor it. And so I get 5x squared minus 10x minus 8x is minus 18x plus 16. Set each factor equal to 0 by the zero factor property. And solve for x. Add 8 to both sides of your equation. Divide by 5. Add 2 to both sides of your equation. And so I have 2 solutions to this absolute value equation. You could have alternatively done it where you said that 2x minus 3 is equal to plus or minus in absolute in parentheses 3x minus 5. And then solve for x, and you'll find that you'll actually get 2 solutions, and the solutions will be the same as what I did here. So let's do absolute value inequalities. So let me move this up just slightly. Okay. And lastly, let's move this up. Okay. So now, absolute value inequalities. So let me look first at the absolute value of x being less than a. So just like what we did with equations, first case where a here is greater than 0. The have to dealt with on a case-by-case basis. So since the absolute value is equal to plus or minus x, we have that x is less than a, and negative of x is less than a. Equation by -1, I have x is greater than negative a. So it says that negative a is less, and x is less than a. So negative x is less than x, and x is less than a. So we'll write it in this 3-part inequality. So automatically, if I have x in absolute values less than a, if a is positive, then x is between negative a and positive a. If x in absolute values less than or equal to a, and a is greater than 0, then x is between negative a and a. Now, if x in absolute value is less than or equal to 0, so I'm doing the case where a is 0. If x in absolute value is less than or equal to 0, well, you can't have that x is less than 0, that absolute value of x is less than 0, because the absolute value is always non-negative. So the only solution is x equals 0. If the absolute value of x is less than a, where a is non-positive, well, then there's no solution, because you can't have that an absolute value is less than a, is negative. If a is less than 0, then the absolute value of x being less than or equal to a implies again that the absolute value is negative, and that's impossible. So this has no solution. So that's how to deal with the less thans or less than equal to's. Now let's deal with greater than. It turns out that we don't really have a three-part inequality notation for greater than. So because of that, we'll need to use our compound inequality notation, not a shorthand sort of notation for it. So we'll have to put an or. Rather than here, we sort of suppressed writing the and by using this three-part inequality notation. So there's no shorthand notation here. If the absolute value of x is greater than a, where a here is positive, then either x is greater than a or x is less than negative. Reason for that, I'll just explain it like what I did above. The absolute value of x is either equal to x or negative x. So either x is greater than a or negative, so either x is greater than a or negative x is greater than a. Multiply both sides of your inequality by -1, so then x is less than negative a. Similarly, if I want to solve the inequality, absolute value of x is greater than to a, where a is positive, then x is greater than or equal to a, or x is less than or equal to negative a. If I want to solve the inequality, the absolute value of x is greater than 0, well, then it means, well, everything has an absolute value greater than 0 except for 0. So that just says that x is not 0. If I want the absolute value of x to be greater than a negative number, well, absolute value is always greater than a negative number. And so the solution is all real numbers. If I want the absolute value to be greater than or equal to a non-positive number, well, x is always greater than or equal to 0. And so it's always greater than or equal to a non-positive number. And so this has, the solution is all real numbers. In general, just remember, I guess it's first inequality here, and there's first inequality here, where you're assuming a here is greater than 0. And then take as special cases all the other ones. Okay, so let's do problem number 48. Solve each inequality, solve each absolute value inequality, express the solution set in interval notation, and graph it. So this is greater than or equal to. So that means that I can't use my three-part inequality notation to simplify the notation for this. So either I have x minus 2 is greater than or equal to 4, or I have that x minus 2 is less than or equal to -4, because I multiply both sides of my inequality by a -1. Add 2 to both sides of my inequality. So x is greater than or equal to 6, or x is less than or equal to, adding 2 to both sides of my equation, -2. So this is going to be the union of two closed intervals. The closed interval from -infinity to -2, along with the closed interval from 6 to infinity. And let me graph this for you. In general, I have a greater than or greater than equal to. In general, it'll be either, well, in general, it'll be the union of two intervals, or nothing, or everything, or 1 point. Okay, so let's graph this. So this is x is less than or equal to -2 or greater than 6. So we are equal to 6 oops. So it's greater than or equal to 6. It is less than or equal to -2. And so it'll be the union of these closed intervals. And that's your answer. Let's do 68. Now I can move this guy up. Solve each compound inequality with absolute value. Express the solution set in interval notation and graph it. I did do interval notation. Yes, interval notation and graph it. Okay, so let's do this. So x minus 3 over 2 in absolute value is between 3 and 5. Well, in this case, let me get rid of the 2, the denominator, by every side of my inequality by 2. And so 3 times 2 is 6. The 2's cancel, so it's absolute value of x minus 3 is less than 10. Okay. So now I have that, well, either x minus 3 is between 6 and 10, or negative 3 is between 6 and 10. Let me add 3 to every side of my inequality. And so I have that x is between 9 and 13, or, well, let's see. Let's simplify this. So let's multiply or change all the signs inside the parentheses. So I have a negative x plus 3 is less than 10. Let me subtract 3 from every side of my inequality in order to isolate my variable x in the middle. So I have that 3 is less than negative x is less than 7. So let's divide both sides of my inequality by -1. Now, if I do that, well, things are going to switch around. So this 3 will go over here. The negative, this inequality will go here. This will go down. This will go over here. And this one will go way over here. And so 7 divided by -1 is a -7. This inequality comes down over here. Negative x divided by -1 is x. This inequality moves over here. And 3 divided by -1 is a -3. And so this looks like let's put here -7, negative, and a 3 and a 9. Okay. So I have that x is between -7 and -3, or x is between these. So either it's this one or that one. And so I have that this is the union, maybe I'll write it up here, of two intervals from -7 of two open intervals, -7 to -3, union 3 to 9. And that is your solution. Let's do problem number 80. Each inequality and express the solution using interval notation. So I can either write this as several inequalities. So several inequalities using the fact that absolute value is equal to plus or minus the quantity inside. So I could have the inequality 3x minus 2 less than 3x plus 1, 3x plus 2 less than the negative quantity 3x plus 1, negative the quantity 3x minus 2 less than 3x plus 1, negative the quantity 3x minus 2 less than negative the quantity 3x plus 1, and then see where those are all satisfied. Or, so I'd have to do the intersection of all those. Or I could just find critical numbers and from there try to find where this inequality is true. Or I can try to solve this using the fact that the square root of a quantity squared is just its absolute value. So I'll do that, but let me first note the following. So I'll just note that is less than, is if A is between 0 and B. So I want A less than B, and I want these to be, then I have that A squared is less than B squared. Okay, so let's show that. Since A is greater than 0, then I can multiply each side of this inequality by A. And so I get 0 less than A squared less than AB. I also have since B is greater than 0, I can multiply each of these by B. Actually, I should make that go a little further out. So then I have that this is, and maybe I'll just, actually, let's just write this. Since A is less than B, multiply by, oops, let's see if it got read yet. So let's multiply by B. So then I have AB is less than B squared. Since B here is also positive. So putting those together, I have 0 is less than A squared is less than AB, but AB is less than B squared. So therefore, I have that a squared is less than b squared. And that's what I wanted to show. Okay, so now let me solve this equation. So I had here my original equation, and let me try to solve it. So let's try to solve this. So I have 3x minus 2 is less than 3x. And of course, these are all positive. So this is the same as 3x minus 2 squared is less than 3x plus 1 quantity squared. Each of these are positive, and so I have that, A is less than B, and these are both positive, so by the above lemma, I can just square both sides. And then the inequality won't switch, and that's what I was showing. And so I have that 3x minus 2 squared is less than 3x plus 1 squared. And so let's square both sides. So so by the special factor, by the special product formula, I have that 9x squared minus 12x plus 4 is less than 9x squared plus 6x plus 1. Notice the 9x squares cancel. So that's good. Let me subtract 1 from both, add 12x to both sides of my equation, divide by 18. And so 1 over 6 is less than x. Let me write that in standard form. So I have that x is greater than 1/6. And so this is just the open interval, 1/6 to infinity. And so let me draw this on my interval. So this is 1/6. Okay. Okay. Notice that if x is greater than 1/6, this is really the only critical number. So actually I can't say. So if x is greater than 1/6, let's say 1, then actually let's do the other side. Let's do 0 first. So let's go on this side. Let's look at 0. And so if I do that, I have 0 minus 2 is 2. 2 is less than 1. So this is false. So on this side, this is a false statement. Whereas pick something greater than 1/6, let's say 1. So this will be 1. 3 times 1 is 3 minus 2 is 1. And so 1. 3 times 1 is 3 plus 1 is 4. Absolute value 4 is 4. So is 1 less than 4? That's true. And so if I fill this in, I have that this is true. which is what we noted before, of course. And so that finishes off section 1.8, and that finishes off chapter 1.